Today we're going to go over the post-test study guide. This is part 2. I'm going to start at problem 25. I'm going to see how far we can get. Remember, this is our hint page. We're going to use a lot of this. If you check out the last video, I tell you which problems use which hint for the first 24. Try to do the same thing again this time. Remember, there's 2 pages. I'd fill out these perfect numbers. You're going to need that. And that's a free point on your post-test. So start with 25. 25, whenever we are adding or subtracting radicals, we want to have the same exact radical. If we can do that, then we can combine the terms in front. So because these are exactly the same, I can take negative 1/2 plus 3/2 in front of the cube root of 20. Negative 1/2 plus 3/2 is 2 over 2, which is just 1 times the cube root of 20. That's your final answer. 26 is a little bit different because these do not match. So you have to hope there's a perfect number that goes inside of them. So I look at my list of perfect cubes. So I have 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. Well, 128 can be broken up into 64 times 2. So 64 is perfect. It turns into 4 outside the radical. So this 4 drops down, multiplied by the 64, turns into this 4. The cube root of this 2 stays in jail forever. Minus 432 is 216 times 2. There are other factors, but 216 is perfect. So that 216, that turns into 6. This negative 2 just drops down, so it's negative 2 times 6 cube roots of 2. I multiply the numbers together, so I get 16 cube root of 2 minus 12 cube root of 2. And my final answer is 4 cube roots of 2. And that's it. I'm going to go over 28 and 29 again because I can't remember if I hit record or not, and I don't feel like starting all over. So I'm going to do 28. Remember, if it's g of negative 1, if it's a composition with numbers inside the parentheses, you're going to plug, it's like plug and chug twice. So I'm going to put negative 1 in for g. So I'll do it just this part first. So I get g of negative 1, and I'm going to do that first. And I can do that. G of negative 1, if I have negative 1 here, I plug it in there, so I get 2 over negative 1. So g of negative 1 is equal to negative 2. Now, I'm going to put negative 2 in right there. So remember, this is g of negative 2 equals, and I'm going to plug it into this. So I say 2 over negative 2. That's going to simplify down to negative 1. My final label is the original label, g of negative 1 equals negative 1. And that's my final answer. 29 is exactly the same, except I do g of 2 first. So I put g of 2. Remember, that's 2 over, instead of x, I'm going to put 2. So g of 2 equals 1. So this spot right here gets crossed out, and I put 1 in. All I can do after 1, so f of 1 equals 2 over 1, which is 2. So my final answer is, and I messed up, hold on. That I just accidentally plugged in g. F is 1 plus x squared, so I got to say 1 plus, instead of x I put 1 squared. So that's 2. So my final answer is f of g of 2 equals 2. And that's my answer. And that's it for 29. Alright, 30 is going to be using this in right here. So 30 is going to be using this idea about inverses. Just to kind of go backtrack a little bit. I don't know if compositions are on here. So 30. Since it says inverse, okay, the first thing I'm going to do is I'm going to put y instead of f of x. So I put y equals 3x plus 3/2. F of x is just a fancy way to say y. Now I'm going to switch the x and y. I'm going to switch those. So I'm going to rewrite this as x equals 3y plus 3 halves. Now I need to get y by itself, so I got to get rid of the 3 halves. I get x minus 3 halves equals 3y. I divide by 3. Remember, I divide both of these by 3. So I end up with y equals 1/3 x, and then negative 3 halves over 3 is minus 1/2. The last thing you have to do is you have to get rid of that y, and you have to write it as f inverse of x. Alright, so that's your final answer right there. And that is D. Alright, you're going to do that every time. Alright, so I'm going to do the same thing for 31, except I'm going to ignore this right now. I'm going to come back to that later, so just ignore that at first. You'll come back and look at that in a little bit. But you're still going to write it as y equals x to the 6th. Now I'm going to switch the x and the y, so I'm going to put x equals y to the 6th. Now I got to get rid of the radical, so I take the 6th root of both sides. Now remember, since that's an even index, when I write y equals plus or minus the 6th root of x. So plus or minus should show up, so even index makes the plus or minus show up. Because that's greater than 0, my final answer is f inverse of x equals only the positive 6th root of x. If that would have been less than or equal to 0, I would have to make that negative, but it's not. That's it for 31. 32, I'm doing the same thing. I put a y instead of f of x. I switch the x and the y, so I get x equals y cubed plus 2. I subtract 2 from both sides, so I get x minus 2 equals y cubed. Now I got to take the cube root of both sides. Plus or minus does not show up because that's odd. So I get y equals the cube root of x minus 2. And then the last thing you do is you put f inverse of x equals the cube root of x minus 2. And that's it. Alright, for 33 and 34, you're going to use this idea of so I'll zoom in. Oh. 33 and 34, right here, it says g of x has to equal x, and g of f of x has to equal x. So that means you're going to plug them both into each other, and you're going to get, it should spit out x every time. So there's going to be two parts to each one of these. So I'm going to do f of g of x, and that should equal x, and g of f of x should equal x. So remember, I'm going to write f of big blank space equals 1/3 big blank space minus 1/2. And remember, I'm actually going to put g of x in there, and g of x is 3x. So I put 3x in right there. Now I'm going to simplify. I get f of g of x equals 1/3 times 3x is x minus 1/2. Since f of g of x does not equal x, they are not inverses. So you don't have to do any more work. It's done. You only have to do both sides if it's going to work on both sides. So let's look at 34. So I'm going to do f of g of x equals x. So that's the first part. I'm going to put a question mark there because I'm not sure if it's going to be true or not. So I put f of big blank space equals 4 big blank space minus 2. So remember, I'm going to put in g of x. So I put g of x in here, which means I put 1/4 x plus 1/2 in there. So f of g of x. See, this is a proof, so you have to have every step. You got to show your work. So I have 4 times 1/4 x is just equal to x plus 2 minus 2. So f of g of x does equal x. It works for there. That doesn't mean it's true, it just means it could be true. So now I have to do the same thing again, but this time I have to do g of f of x equals x. So now I'm going to start with g of big blank space equals 1/4. Instead of big x, I put big blank space plus 1/2. Now I'm going to put in f of x. And f of x is 4x minus 2. I distribute. I get g of f of x equals x minus 1/2 plus 1/2. Those cancels. So g of f of x does equal x. So now your answer, you say, since both work, they are inverses. And that's it for 34. 35. Sketch the graph. Determine whether the inverse is a function. So, sketching the graph is easy. I just make an XY chart. I'm going to pick -1, 0, 1. Plug -1 in, I get -6 minus 3, I get -9. Plug in 0, I get -3. Plug in 1, I get 3. If you want to do 2, you're going to get 9. It doesn't. So I have 0, -3, 1 up to 3, -1 down to -9. Make my graph. Alright. So there's the graph. The inverse is a function because it passes, it's called the horizontal line test, which means if I drew lines all throughout that, on all infinitely many times, they would never cross that line twice. Alright, that's all you have to do. That's called the horizontal line test. So the graph never touches horizontal line more than once. That's how you know. That's what the horizontal line test is, and it passes it. All right. As soon as you see a graph, you make an XY chart. Now, normally I pick -2, -1, 0, 1, and 2. I'm not going to pick negative numbers because of that radical. If I pick a negative number, I'm not even going to pick 0 because 0 will make imaginary show up. So 1's the lowest number I'm going to pick. I pick 2. I could pick any number I want, but I'm going to pick numbers that give me a perfect square. So I'm going to pick 1 because 1 minus 1 is 0. I'm going to pick 2. I could pick 3. I could pick 4, but I'm going to pick 5 next. All right. So I plug it in. I plug in 1 right there. I get 2 plus the square root of 0, so I get 2. Then I plug in 2. I get 2 plus the square root of 1, which is 3. I don't even worry about 3 and 4. They work, but they're decimals. So I plug in 5. 5 minus 1 is 4, so I get 2 plus the square root of 4, so I end up with 4. I'm going to put over 1 up 2, put a dot. Over 2 up 3, put a dot. Over 5, go up 4 dots. And your graph should look like this. Make sure it only has one arrow. And that's it for 36. On the post-test, a problem like this is going to be a multiple choice, but on this one it's not. So we're just going to do everything we've been doing, which is we're going to make an XY chart. I'm not going to pick any negatives because of the radical, so no negatives. I'm going to pick 0, 1, 2, and so forth. I plug in 0. I'm only going to pick perfect squares. So I want those to be perfect. So I'm not going to pick 2. I'm going to pick 4 and 9. 0 goes in, the square root of 0 is 0, plus 2, 2. I plug in 1, square root of 1 is 1, plus 2 is 3. I could pick 2, it's just going to give me a decimal, and I don't want it. So I plug in 4, square root of 4 is 2, 2 plus 2 is 4, square root of 9 is 3, 3 plus 2 is 5. So I go 0, 2, put a dot, 1, 3, put a dot, 4, up to 4, put a dot. If I want to put 9 and 5 on there, it's going to be right there. Remember, one arrow. It does not go to the left of the y-axis. It does not go below 2. If I wanted to, I could say the domain and range. That's it for 37. I'm actually going to graph 38 because it's easier to find the domain and range. So I'm going to graph 38 right here just because it's easy to find the domain and range. Remember, domain is where the x values are at. The range is all the y values. So I'm just going to graph it. I'll make an XY chart. Remember, I can't pick negatives. I can't even pick 2. Because if I put 2 in there, I'm still going to get negative radical. So the lowest number I can pick is 3. Because 3 minus 3 is 0. If I pick anything other than 3, or anything smaller than 3, I'm going to get a negative, which makes imaginary show up. I'll pick 4. I'm going to pick 7. So I like 7 because it makes 4 inside the radical, which is perfect. So 4 minus 3 is 1, so I get square root of 1, which is 1. 7 minus 4 is, or 7 minus 3 is 4, square root of 4 is 2. So I have 3, 0, dot, 4 up to 1, dot, 7 up to 2, dot. Now the domain is all the x values. Now there's a fancy way to write it. You don't have to necessarily write it this fancy. As long as you have most of it, it's fine. But really you should say, there's a math way to write it where it says x is in the reals. So that little symbol between x and the r is, it means in. That's a fancy way to say all the real numbers, the r with a double bar. The line means such that x is greater than or equal to 3, because you're allowed to use 3. The range is y is in the reals such that y is greater than or equal to 0. So if I look at this graph, it goes to the right forever. That's why it's greater than 3. It does not go to the left forever. It stops at 3. That's why it always has to be bigger than 3. Y is up and down. The graph goes up forever. It does not go down forever. There's nothing lower than 0, which is why I say y has to be greater than or equal to 0. 39, I'm going to use pen in reverse. So I have the cube root of 3x plus 2 minus 7 equals negative 6. So I'm going to use pen in reverse. Alright, I see subtraction. So the first thing I do is I get rid of the plus 7 on both sides. So I have the cube root of 3x plus 2 equals 1. Now there's the subtraction. There's addition, but technically, guys, there's parentheses if it's inside the radical, so I can't get rid of the addition yet. There is no division. There's multiplication also inside the radical, so I have to get rid of the exponent. That's why I cube both sides. So I have 3x plus 2 equals 1. Now it's a simple solve problem. So I cube to make the little 3 go away. So I subtract 2 from both sides. I get 3x equals negative 1. X equals negative 1/3. You do want to plug it in to make sure it works, because if it doesn't, it's possible that you can get a right answer math-wise, but get a wrong answer as in it's not possible. But in this case, it does work if you plug it in. And that's it for 39. Alright, 40, same way as we just did in 39. So I have 7x minus 4 inside the square root is less than or equal to 4. I square both sides. So I get 7x minus 4 is less than or equal to 16. I add 4 to both sides. I get 7x is less than or equal to 12. And then I divide by 7, so I get x is less than or equal to 16 plus 4 is not 12, it's 20. So I get x is less than or equal to 20 over 7. D. That's it for 40. Alright, sketch the graph. F of x equals 3dx. Remember, anytime you say sketch a graph, just make an XY chart. You're guaranteed to get 2 points if you fill it out. I'm picking the x's, so I'm going to put 1, 2, 3. Actually pick 0. negative 1. So I'm going to change this graph a little bit. I'm going to pick negative 2, negative 1, 0, 1, and 2. If I don't know what else to do, that's a good place to start. I plug in negative 2. 3 to the negative 2 is 1 over 3 squared, which is 1/9. Negative 1, 3 to the negative 1 is 1 over 3, so 1/3. 0, anything to the first power is 1, or to the 0 power is 1. I get 3, I get 9. So I go over 2, up to 9, put a dot, over 1, up to 3, put a dot, 0, 1, negative 1, negative 1/3, and then there it is. And this goes on to the left forever, but it never crosses 0. It never crosses 0. So it goes up and goes up and gets really big really fast. And that's it for 41. Alright, if there are initially 4,000 bacteria in the culture, and the number of bacteria double each hour, the number of bacteria after T hours can be found using this formula. After 9 hours, you're just going to plug in 9 for T. So I say N equals 4,000 times 2 to the 9th. So you get 4,000 times 512, which is 2,048,000. Alright, 43. Explain the difference between linear function and exponential. Linear. Constant rate. Exponential. Changing rate. Like a line goes straight up, goes at a constant slope. Exponential either gets really, really big really fast, or it gets really small really fast. Alright? So, changing rate. Or slope. Alright, 44, once again, will be multiple choice on your post test. Just going to make an XY chart here, so I'm going to make my XY chart. I'm going to put negative 2, negative 1, 0, 1, and 2. I'm going to say 1/5 to the negative second power. So it's just going to be 25. Negative, if you just type in your calculator, or 1 over 5 to the negative second, then it goes on top. Negative 1 is to the 5th power. 0 is always 1. 1/5 to the first is 1/5. 1 over 1/5 to the second is 1 over 25. And if you're not sure how I did that, I just did 1/5 to the second. It goes to the top and the bottom, so I get 1 squared over 5 squared, which is 1 over 25. So left 2 way up to 25. I'm going to make these go by, I'll say 5. So I'm going to go left 2 up to 25, put a dot. Left 1 up to 5, put a dot. 0, 1. And it's going to be really, really close. But remember, it's never going to touch. There is a dotted line here that's called an asymptote. Right? Dotted because it's not part of the graph. It's called an asymptote. And that's it for 44. Alright, so use the PERT EP. This is if it's if your interest is compounding continuously, you're going to see how quick your money grows. That's why banks don't compound continuously, because it's just crazy. But if you have $4,500 in account, that's going to be P for principal. Alright. R is the rate, so 9% is 0.09. T is time, compounding continuously after 5 years. So my formula is going to be 4,500 E to the 0.09 times 5. So I just type that into my calculator. I end up with $7,057.40. And since it's a dollar amount, I'm going to put dollar amount. So in 5 years, you get $3,000 worth of interest. It's a pretty good deal. It's why most places don't do that. All right, you could type that in your calculator. You type in, or you could realize that ln and e cancel each other out. So you're left with ln e to the fourth is just equal to 4. Now the reason, so 40, that's all, 48. The reason you use change of base is the only time you can use your calculator. The log on your calculator is log of base 10. It's the only one on your calculator. They don't have every log on your calculator. So you can't put that in your calculator. If you put log of 4 on your calculator, that's actually using log of base 10 of 4. So to do log, you use a change of base formula, which says you take log of the top, and I went to base 10, over log of the base in base 10. Now I can type this in my calculator because log of 10 is in my calculator. And I get 1.26. And that's it for 48. Find the inverse given model. Alright, so Celsius, if I switch the variables, that's finding the inverse. The inverse is switching the letters. So I'm going to have F equals 5/9 C minus 32. Now I'm going to solve for F, or for C. So I'm going to have, I'm going to multiply both sides by 9/5. So I'm going to have 9/5 F equals C minus 32. And because C and F mean specific things and we didn't use like f of x, I actually don't want us to change the variables. I'm actually just going to solve this equation for the other variable. I don't need to switch it. So I'm going to multiply both sides by 9/5 to make this go away. So I'm going to multiply it by 9/5. I do it on both sides. So I get F minus 32 equals 9/5 C. Now I add 32 on both sides, so I get F equals 9/5 C plus 32. So that's my formula to get Fahrenheit. So this is actually, if you don't know, this is a formula to turn Celsius. The original one is to turn Fahrenheit degrees into Celsius degrees. The inverse goes Celsius to Fahrenheit. I think why would we use the inverse? Because we use Fahrenheit in the US. If we visit another country, we might need to change. So we understand, because 35 degrees Celsius might not mean much to us, but if you would change it to Fahrenheit, it would mean a lot. Alright, 50. Common log has base 10, because that's what's in our calculator. Natural log has base E. That's it. That's the difference. And we finished the post-test study guide. So that's it.